Alright, today we're going to multiply and divide radical expressions. Remember to pause to copy down the information. Alright, here we go. Our first example. If we apply the rule, we have to notice a few things, first of all, before we can apply the rule. We have to notice that the 3 and the 3 are the same number, and an n. Okay? And then we have to notice that they have to be real numbers. So is the cube root of negative 3, is that a real number? Would the square root of negative 3 be a real number? No, but is the cube root of a negative number a real number? Yes. So that's a real number. In the cube root of 9, that's also a real number, right? And so we can apply the rule. The rule says that since the cube root of negative 3 times cube root of 9 are both real numbers, then I can blend them together as the cube root of negative 3 times 9. Okay, I'm going to go real slow, okay? To make sure that you don't lose what's going on here. What is negative 3 times 9? Negative 27. Okay? Now, if we don't know what that number is, we could do it on our calculator. Negative 3 times negative 3 times negative 3 is negative 27. So since negative 3 cubed is negative 27, then that means the cube root of negative 27 is negative 3. So kind of using the language that we used last Thursday. Okay, we're going the other direction now. Okay. So what do you think the answer is on number 2? Let's walk through it. 4 and 4, are they the same? Okay. Is this a real number? Yes. Is this a real number?
Yes.
I hear both answers. Okay. Okay, can't get a root 4 and get a negative? In other words, what you're saying is there's no way to take a number, multiply it by itself 4 times and get a negative number, right? For example, 2 times 2 times 2 times 2 is going to be a positive number, right? And negative 2 times negative 2 times negative 2 times negative 2 is going to be a positive number. So there's no way to make this happen, so this is not real. And so we'd say no solutions. Okay? It's not a real number, so we cannot get a solution from that. Okay, number 3, we're going to look at this going the other way. We want to simplify. There's nothing to multiply here. It's already multiplied. We just want to simplify. And so I'm going to break this down this way. 54 times n8. And again, this whole chapter is full of, absolutely packed with problems that can be done multiple ways. And AJ might look at this and say, well, can't I just do this and that and then be done? Probably you can. And someone else will look at it and do it a different way, and they'll be done also. But we're looking for cubes. And some of you will look at 54 and not know what that number is. And so I'm going to suggest that we look at the prime factors of 54. Okay? Others will look at it and say, I know that's 27 times 2. Some of us will look at it and not know what it is, though. So I want to give you a way of discovering what it is. Plugging it into your calculator many times will not give you the answer you need. but 54 is an even number, so 2 will go into there. And I chose 2 because that's the smallest prime number. And since 2, the smallest prime number, goes into 54 27 times, now that's an odd number. 2 won't go into 27, will it? And so I go to the next prime number, which is 3. And 3 goes in there 9 times, and 3 still goes into there again 3 more times. And so 54 is equal to 2 times 3 cubed. Now, this is not a big number, and I realize that we just did what cube root 27 is. But still, I want you to have a backup plan in case you don't recognize the number. And so I'm going to write this as the cube root of 3 cubed times the cube root of 2. And then I'm going to write this one the same way I did before. I want n cubed here. Sorry, that's not writing very well. Because it needs to match this cube. And how many times can I pull 3 out of 8? 2, right? And so n squared cubed would be n to the 6th, right? And then I really need 2 more of them, don't I? Because I still have to have 8 of them. So inside I have 6 of them here. 2 times 3 is 6, and then 2 more out here. And so if I apply yesterday's rule to this, yesterday meaning last day we talked about it, I think it was Thursday. Cube root of 3 cubed is 3. Okay, so that one's gone. Cube root of n squared cubed is what? What's the cube root of n squared cubed? It's n squared, that's right. I skipped a what? No, I didn't, yeah. It's on pause. Okay? I could have circled it so I didn't forget it. That would have been a good plan. But I was taking care of all the perfect cubes first. Okay? And so my 3 cubed I took care of here. My n squared that was cubed, I'm going to take care of that here. Now I'm going to go back and say, okay, what's left over? I have a 2 and an n squared. And so my answer is 3 n squared cubed root of 2n squared.
Can our n squares cancel?
No. Not dividing, and even if I were, this is the cube root of n squared, so that's not really n squared. Right? The square root of 8 is not really 8, right? It's less than 3, right? The square root of 9 is 3, so square root of 8 would be a little less than that. And that's where it gets difficult. You have to get in the habit of recognizing that when there's cube roots, fourth roots, okay, that they're not really that number. Okay? Kind of a jumbled mess here. Any questions on this one before we move on to the next one?
There's a question on that?
All right, let's go to the last one here. Again, we have cube roots. We have multiple variables, multiple powers. There's more than one way of looking at it. Sometimes I like to just write it all as 1 and start putting things together like 25 and 5. I can call it 125, or I could call it 25 is really 5 squared, right? So I could call it 5 squared times 5, or even 5 cubed. So I've got some options there. X times x to the 4th. I'm just going to put them all together first. And then y to the 8 times y to the 3rd. I just took all my terms that were like terms, and I'm going to put them together so that they're next to each other. Okay? And I'm looking for groups of 3. And we said this could be rewritten as 5 squared, and that's 5 to the 1, so this is really 5 to the 3rd power. And if I break this up into 3s, well, how many are there altogether? 5. So how would I break that up into 3s? X squared squared times x. That would be a great plan when this number was 2, right? But I need 3. I need a group of 3. So if I do that, I get x cubed, right? And what? And an x squared. So I can't do it this way nice and simply, can I? I just get the x in there. I don't get an x squared or anything else. That just doesn't work on this problem. Okay? It's the right idea, the right way to think about it, just doesn't work with these numbers. So let's move on to the y. How many are there altogether? 11. So if I break them up into 3s, break them up into 3s, how many do I get in here? 3, right? 3 times 3 is 9, leaving me with 2 more left out there, correct? This concept right here just dawned on me. Might be very confusing to some of you. You might like it better if you just wrote this as y cubed, y cubed, y cubed, y squared. What do they add up to? 11. You might find it easier to look at it this way. And then you're going to cancel a y, a y, a y, and you're left with, out front then 3 y's. Okay, so whichever technique works better for you, don't be afraid to use it. Yep. Doesn't class end like at 16 after? Okay. All right, so let's finish this. What comes on the outside? 5. Because then that cancels with that. X, and then that cancels. Y cubed, that's these 3 or this one here, however you want to look at it. Any others come out? No. So then we go cube root of what's left. Well, we skip this one, x squared, and we skip this one, y squared.
Alright, you don't want like parentheses around the cube root.
Oh.
Can you add them?
So it's not like y
Yeah.
to the 33?
Yeah, you do have to be careful. I'm not going to say you have to put parentheses there, but you certainly have to be careful how you write your variables and your exponents, next to the roots. So it doesn't look like you said 33 power or the 33rd root. Okay? So be very careful with that. All right. Any questions on that? I think I just have one more, and then there's like 4 examples for that. Ready? So we're going to turn the page, we'll copy it down, pause while you do that. All right, last page of examples. I think there's just 4 more here. Yep. You'll get time to write that down just a minute. Dividing radical expressions. The key here again, these have to be real numbers, so square root of, or 4th root, or 6th root of a negative number doesn't work, okay? Ends have to be the same. And now instead of combining them as multiplying, we were dividing, so we're going to divide inside the radical sign. And so if I rewrite this one as 1, quite often that's the easiest way to go. I'm going to write it as a cube root of negative 81 over 3. Is that a real number? Yes, it is, because it's an odd root. And it's okay to have the odd root of a negative. It's going to work out. What's negative 81 divide 3? Negative 27. Now we've had 2 examples already with this in it. So hopefully do we now know that the cube root of negative 27 is negative 3? Because negative 3 times negative 3 times negative 3 is negative 27. Okay? So if I apply the same procedure with the second one, how would I rewrite that? Can someone tell me how to rewrite that nice and loud?
Would it be 3 the square root of
You mean cube root
cube root, yeah.
of what?
192x over 3x. Well,
192
x to the 8th
x to the 8th over
3x.
3x. Okay? My 92 looks kind of like a 42, but that's 192. What can I do now?
Don't we have to reduce the 8 or something?
Okay, how do I do that?
Do x times 4 or something.
Oh, I see. Yeah, why don't we simplify what's in here first, though?
64.
You're saying 192 divided 3 is
64.
64? Yeah, and if I have this x to the 8th power means I have x times x times x times x times x times x 8 times, right? Over 1x. So one of these will cancel with one of those, right? So that gives me x to the 7. Now some of us are pretty good at recognizing, I guess I'll go over here. Oops. 64 is what? What's the cube root of 64?
4.
4. If we didn't, again, we could go, oops, let me get a marker. We could go 64, 2 goes into there, 32, 2 goes into there, 16, 2 goes in there, 8, 2 goes in there, 4, 2 goes in there, 2. So how many 2's are there? 6 of them. Which is 2 squared cubed, right? And so I could use that same process, and the cube root of 2 squared cubed would be 2 squared, which is 4. Then I'm going to break my x's up. I'm just going to do it right here. X cubed times x cubed times x. Is that 7?
Yes.
Okay. Or I could have written it as x squared times x squared cubed times x. So depending on which method that works best for you, I can break it up into groups of 3 because that's what I'm looking for with this cube root, and use x cubed, and then whatever's left over. Or I could break it up as a power with a cube and say what would have to go inside. Well, 2 times 3 is 6, plus 1 more would be out here. That's how I got this. Okay? So it's your choice how you decide to break that up or how you look at it. And if you struggle on it, then just ask for more help, and we'll try to work with the process that you're used to best. And so what do I get? How many x's do I get when I bring them out? 2 of them, right? Either this one or each of these. So I get squared times the cube root of x, the one that's left over. So I get 4x squared cube root of x.
Would the number 3 be no solution because there's no ends involved? Or no outside?
Yeah, that's a 2.
Oh, yeah.
Okay? If we go back to the directions, it said rationalize the denominator when necessary. Okay? And so on number 3, that's what we're doing right now. If you remember from geometry, you cannot leave a radical sign in the denominator. So we have to rationalize that. So we're going to multiply top and bottom by square root of 5. The reason is because what's the square root of 5 times square root of 5? Square root of 25, which is 5. In other words, my square roots cancel, don't they? So no longer have a radical sign, the square root or cube root or whatever it is. In this case, it's square root. I no longer have a radical sign in the denominator. So on the top,
Square root.
what is square root of 3 times square root of 5?
Square root of 15.
Square root of 15. And that's all I can do there. Too often people look at that and say, well, can I cancel my 5 out of my 15?
They're different.
Remember, that's not a 15, is it? It's the square root of 15. And so, let me separate this work a little bit. One thing I want you to realize is never cancel factors. I don't know why this won't write. Inside a radical with factors outside the radical. Okay? Never cancel factors that are inside the radical with factors that are outside the radical. So this is outside the radical sign, this is inside the radical sign. Do not ever try to cancel them, it doesn't work. It gives you wrong answers. Okay? Go ahead.
Well, why do you rationalize that one if, like, you don't rationalize the first two?
I could have, but in the first two they simplified
Oh, okay.
to a simple answer before I had to. You know what I'm saying? In this case, I couldn't simplify these two any other way, so all that was left was to rationalize the denominator.
So you can always rationalize the denominator if it...
I can. I could have rationalized these up here first, but then when I was done, I would have had an extra 3 on the bottom and an extra 3 on top, and I would have had to have canceled them.
Yeah.
I would have gotten like a -9/3 and then ended up with -3. I would have had to have reduced when I was done. Okay? And so what I suggest, like in this next example, yes, I'm going to be able to simplify some things, and yes, I'm going to have to rationalize. And so I'm probably going to simplify first, and then rationalize what has to be rationalized. Because rationalizing would be the messiest part of the assignment. And so if I can simplify it and not have to rationalize every time, or as much, then that's the way to go. Okay? So, the last one, x to the 5th. If I write that as 1, because they're both square roots, I get x to the 5th over 3x squared y. What happens to my x squareds?
They cancel.
They cancel, leaving me with 3 of them left on top, right? So I get x cubed on top
Right.
and
Wow.
3y on the bottom.
Wouldn't we leave it like that?
No, because I have a radical sign in the denominator. And so I'm going to rewrite this as square root of x squared. And if I want, I can write it as x squared times x. And on the bottom, I'm going to have the square root of 3y. And none of this simplifies, does it, the 3y? 3 is one factor and the y is one factor.
So then now you rationalize.
So now I'm going to rationalize. Let's do one more thing as I do this. I will in just a second. Let me rewrite it. To rationalize and multiply by the same number, here, I need to slow this down a little bit. Both examples that I've chosen were square roots. If this were a 3, I would need 3 factors, not just 2.
Well,
Because it's a square root, I need 2 factors of 3y. If it was a cube, I would need a 3y, a 3y, and a 3y. And if I already had one of them, then I would call this 9y
Square.
squared.
So you can just multiply by 9y squared, top and bottom, right?
Right. If it was a cube, I would multiply top and bottom by 9y squared. Okay? If there's, I think there are problems like that on the test, or on the homework, and tomorrow, when we go through it, we can clean up any of those that we're confused on. So on top, what is square root of x squared? X. And then I say, what's left? Well, an x times a 3y, so that's 3xy over what?
No, why?
3y, square root of 3y times square root of 3y is?
9y.
It's actually square root of 9y squared, which reduces to 3y. Okay? Now, when you're done, always do a double check here. Numbers outside, do any of them reduce? No. Okay?
How'd that x get outside the radical?
I had x cubed, which is x squared times x. And the square root of x squared became x.
Oh,
And then the square root of x that was left over is still inside. Okay? All right, your assignment today, and I'll give you some time tomorrow to clean up, finish it up, but do the best you can tonight. 3 to 33, these are all threes, all by threes. So not as many as it looks. It's like 16 problems there. 3 to 33, 42 to 51, and number 63. Okay. Again, emphasize that the grade you see is 99% not going to be the grade that's going to go in there. We'll figure out how you can make up for this, okay? So, Megan McDonald, come on up, look at your score. I'm not passing them back at this time, just look at what this raw score says, okay? Taylor? Trent? Mackenzie?
It's not an F.
Brady? Matt?
results every
I gotta know what I thought.
Next.
It's like art. I don't know how I got this. I thought I was either gonna be like 40, 55.
Creativity. And then I just yelled out secret.
What'd you get? I already said it. Yeah.
You didn't stop our recording.
It does play.
It's still on.
Sorry about that. Recording's a little extra long.